Okay, good morning class. So today we're looking at differential calculus. We're looking at the examples for exercise 13, and exercise 13 is on page 174, and I'm looking at example 1, and example 1 is on page 171. Example 1 is on page 171. Okay. Okay, so today we're looking at determining the equation of a cubic function. Okay? You may determine the equation of a cubic graph with or without using a sketch. That we are told. If the x-intercepts are given, then we use the formula y is equal to a minus x1 into x minus x2 into x minus x3. Remember, when the two x-intercepts of the parabola is given, then we use the formula y is equal to a into x minus x1 times x minus x2. However, for the cubic function, we add the x in x minus x3 as well, the third x-intercept. Okay, so let's look at the example 1 on page 171. We are told that if f of x is equal to ax cubed plus bx squared plus c x plus d. Now that is the standard form of a cubic function and passes through the point negative 3. So if I should draw it, it's going to do something like this. There's negative 3, negative 1, negative 6, and of course the y-intercept is here, and 0 and 4, which is there. Okay, so the graph must be doing this. Sorry, 4 and 0 is on your y-intercept, not so. 4 and 0. Wait, then I'm doing it completely wrong. Not 0 and 4. Oh my word, what's it now? I need to write a bit slower because the board is not playing along. So that is negative 3, negative 1, 4 and 0, approximately there. It's actually further that side, comparison to 3. And then it's cutting minus 6. Let's say minus 6 is there. So the graph must be doing this. Okay. Of course, it's now not as it's showing there. You need to align the board quickly. Okay, so that's what the graph is going to look like. You can't go the other way, otherwise you won't cut negative, your y-intercept at negative 6. Okay, again, do we need to draw this graph? No. Okay, the question says determine the values of a, b, c and d. Okay, so if we've got this form and these points, people, we know that since we got the x-intercepts, what do we say? Y equals a into x minus x1, x minus x2, x minus x3. So we now say y is equal to a into x. Now the first x value is minus 3, so it will be plus 3. X minus minus 1 becomes plus 1, and x minus 4. If you started with minus 4 and then minus 1 and then minus, there's no problem, people. Okay? I'm just starting from one side and working my way through. Okay. Another thing is, if the graph did this, is turning on this axis, then you follow y is equal to, and that was minus 1 and that was 2 for argument's sake. Then it's going to be y is equal to a into x minus minus 1 into x minus minus 1 into x minus 2. Why? Because the graph is bouncing off at minus 1. So that's a 2-in-1 solution there. Or I could have written it as y is equal to a into x plus 1 squared into x minus 1. X minus 2. Okay, so just consider that as well. I don't think one of the examples have that. Alright. So what still needs to be solved here, people? The value of a. Can you see that? The value of a still needs to be sorted out. So what we do is we substitute 0 and negative 6. Remembering that's a x and a y. So negative 6 is equal to a into 0 plus 3. 0 plus 1, 0 minus 4. So that's going to give you 3 times 1 is 3 times 4 is negative 12. 8. So therefore a is equal to half. Do you all agree with that? See any confusion there? No? So what does my equation now read? The equation now is y equals a half into x plus 3 into x plus 1 into x minus 4. Let's just multiply this out. It will be a half into x plus 1. There will be x squared multiplying these two binomials. It will be x squared minus x minus 12. Okay? Now multiply x plus 1 in, so it will be a half into x cubed. That will give you negative x squared. That will be positive x squared, so that cancels. That will be negative 12x minus x, negative 13x. And the last term squared is going to give you negative 12. Okay. So now to get rid of the half, so it will be a half x cubed minus 13 over 2x minus 6. So my a value is a half. So you just underline it because that's within the sum. My b value is negative, not my b value, but my c value. My c value is negative 13 over 2. My d value is minus 6 and my b value is 0. Okay. Do you guys understand? Is there any confusion? Goliath? Is there confusion, Michael? No. You all understand, huh? So let's look at example 2 on page 171. If you didn't understand, you can rewind the video and watch it again. Okay. Now I'm going a bit fast through it, but we, as you know, we are pressed for time. So at least you have a backup explanation. Okay. Example 2 is also on page 171. We are still determining the equation of the cubic function. So it says consider the function f of x equal to ax cubed plus bx squared plus x plus d. If f of 1 is equal to f of 4, which is equal to 0. People, when do we set f of x equal to 0? When do we set f of x equal to 0? Recalculating the y-intercept. Your x-intercept. Okay. So in other words, these are x-intercept values. So in other words, x is equal to 4 and 1. Okay, so there's your y-axis. f of 3 is equal to 0. So that means you say the graph is going through 3 and 8. Not so. What does this mean, people? F prime x. F prime x is your derivative, first derivative. When do we set the first derivative equal to 0? When do we set our first derivative equal to 0? We're working out our turning points. So what does that mean? That means to say the graph is turning at x is equal to 1. So the graph must be bouncing off the axis there. and it's turning at x is equal to 3. So the graph needs to do this. So that's the a rough sketch of that graph. Okay. Now coming back to this point 3 and 8, where's that? On the turning point. Okay. You guys understand? Must I do it again? No. Okay. Must I do it again? Yes. Oh, and then you must open your mouth. Alright. So let's go again. Consider the function f of x equals ax cubed plus bx squared plus x plus d. We know that that is a cubic function. How do we know that? The highest exponent on x is 3. So if f of 1 is equal to f of 4, which is equal to 0, what does that mean? When do we set f of x equal to 0? When we work out our x intercepts. Can you see that? So that means to say the graph is going to cut at 1 and at 4. Okay. Then we say f of 3 is equal to 8. So that's x is 3 and y is 8. So that's a point on the graph. Okay. This is also 4 and 0 is also a point on the graph, and 1 and 0. But because of the 0, we know it's your x-intercept. You understand? Okay. When do we set f prime x equal to 0? When we work out our turning points. So which means to say the graph is turning at an x value of 1 and an x value of 3. So if you look at 1, what do I notice? 1 is on the axis. So if the turning point is on the axis, the graph is bouncing off the axis there or like that. You guys see that? And it's going through and turning point of 3. So I say x equal to 3. Now I can't let the graph go through like this because the graph is going through 3 and 8. Can you see that? So it can't go through 3 and 8 there because this is on the negative part of your y-axis. That is why it has to be on top. You guys understand? Let's take it back. So the graph has to come down like this, and then up, and then down. But it's turning here at 3 and 8. The graph must go through 3 and 8. Why? Because of this information here. Okay. Right, let's answer the question. It says draw the sketch of the graph of f indicating the x-intercepts and the turning point or points. Right, next question. So that's number 1. Number 2. Determine the values of A, B, C and D. So where do we start? We start by saying there are 2 x-intercepts. Actually 3 to us. Not so. Why? Because I just 2 in one solution at x is equal to 1. You all see that? So what's my equation? Y equals A into x minus x1, x minus x2, x minus x3. Otherwise, since we know that, we could have written it as y is equal to A into x minus x1 squared into x minus x2. That's the same thing that could have written there. Y squared because this is a 2 in 1 solution there. You guys understand? So let's cover that. So I say y is equal to A into x minus 1 times x minus 1 into x minus 4. So what needs to be solved now? What do you need to solve now? A. Not so. So what do? I substitute a point that wasn't used yet. So let's substitute. What do we have? We'll substitute 3 and 8. Remembering that's a x and a y. Okay? So let's substitute what we have. 8 is equal to A into 3 minus 1 squared into 3 minus 4. So 3 minus 1 is 2. 2 squared is 4. 4 times negative 1 is negative 4. So negative 4A is equal to 8. So A is equal to negative 2. Can you see this graph is first coming down then up? Can you see that? and hence it explains your A value being negative. Okay. From here, it's just a matter of simplifying. So that would now read y equals negative 2 into x minus 1 squared into x minus 4. So y is equal to negative 2 into x minus 4 into x squared minus 2x plus 1, which gives you negative 2 into x cubed. That is going to give you negative 2x squared minus 4x squared. It's minus 6x squared. Okay? So it's going to be x times 1 is x plus 8x is going to give you an answer of 9x. Is that correct? So it's 8x plus x is 9x minus 4. Okay, now it's just to get rid of the outer bracket, so it's negative 2x cubed plus 12x squared minus 18x plus 8. So now I can conclude, therefore, now my A is sorted out already. My A value is minus 2. I just underline it because that's within calculations there. Okay. So the examiner knows where to make your tick for A. So your A value, so your B value is equal to 12, your C value is negative 18, and your D value is 8. Okay. Is that correct? Otherwise, you could have listed at the top of B the value of A is equal to minus 2. There's no harm in that, okay? Any confusion here? No? Yes, my girl? I thought you were going to ask me something mathematical. Never? You can go quickly. Yes? 2 in 1. 2 ones. Because of the graph. Remember when we work out our equation of, when we work out so you're asking why is it 2 ones? You see, if I take that down, can you see there? Did I have a value less than 1? A value more than 1? And the value is less than 4. Can you see that? So what happens is, as I bring this up, what do you notice? That 2x values along the side, what's happening? Becoming closer and closer and closer until it's on that axis. So those two values become so close it becomes the same value. Okay? And then if it goes above that, it is only one x-intercept. Okay? Likewise, if you take this graph and you bring it down, what do you notice? There's two values and 2 here. But on the right hand side, what do you notice at 3 now? The 2 values becomes 1 value. And where does it become 1 value at? That x is equal to 3. Can you see that? So when it's on the axis, then it's a 2-in-1 solution. Okay. So when you just take it one step back again, when we had parabolas and it was in the form of y is equal to let's just use a parabola here, x minus 1 squared. And I worked out my x-intercept. We knew this parabola was smiling, but the turning point occurred at 1 and 0, because that was plus 0 here, not so. So the graph is smiling. So what do you notice here? Again, there's a 2-in-1 solution here. Makes sense? So that's how I know it's 2 ones at that point. Okay? Alright, let's look at example 3. Okay, and I think I'm going to stop at example 3. How many examples are here? We have 5. Okay, so I don't think it's fair to do all 5 and then it's a lot to absorb at once. So I'm going to do number 3, give you homework on it, and then Monday come, we'll do the next 2. Is that okay? Right. So you're looking at example 3. Example 3 is on page 172. Example 3 is on page 172. So here we are told of a cubic function. F is a cubic function. Okay. Consider the sketch of the derivative of f given by f prime x equals ax squared plus bx plus c. Just to refresh your memory, we spoke about this already. If f of x is a function of a cubic graph, the graph will look like that. Its first derivative will be a smiling parabola. The second derivative will be an increasing straight line graph. Not so. Likewise, if the function is given as a cubic function with a negative gradient, that's a is greater than a value of negative, the graph will first go down, then up. The parabola will be frowning and it will be a decreasing straight line graph. Okay, if you didn't know that, make that note there. So this is a smiling parabola. Can you see that? So its original function must be looking like that. Okay. So if you get this question in the exam, that's the first thing you draw. You draw the spot here. Okay. So that I know where I'm going. Okay. Okay. You guys got this? Can I take it off? So write down the x coordinates of the stationary points. I had to take it off. So the x values of the stationary points is, if I draw an x-axis through here, okay, the x-intercepts of this parabola, the x-intercepts of that parabola will of course be the turning points of the original function. Remember in the exercise 12, when we did that equation, the drawing of the graphs and answering those questions, I see many of you are pulling your face as if what they're talking about. It shows that many of you weren't doing your homework. Okay? You just write it neatly out here. Just refresh your memory. That if this was the graph, okay, that is f of x, that was your turning points. Not so. Then the derivative function will cut your x-axis at those points, at those turning points. This is your derivative function. If you didn't know that, please write it down. Okay, and for those of you who I'm seeing on the phone, I don't know. Okay. Here is your second derivative. Now your second derivative actually goes through the turning point of the quadratic function. The axis of symmetry of the quadratic function actually goes through the axis of symmetry of the quadratic function goes through the point of inflection of your cubic function. Your second derivative, in other words. And if I must draw your second derivative function on here, this is what it's going to look like. It's going to cut your x-axis at that point of inflection. Okay, that's your second derivative. And the reverse is also true. Okay? If the graph goes down then up, then on your turning points, that is where your derivative function at the turning points, your quadratic function is going to cut your x-axis, and at that point of inflection, at that x value, the second derivative will cut the x-axis. Oops, that's 1 and 1. Okay, very, very important to make that a link between those values, those x values. Okay, yes?
Is the point of inflection also the turning point of first derivative?
Yeah, it's the axis of symmetry of your first derivative. It forms the x value or the x coordinate of the turning point is. Okay. Any other confusion? Very, very important to notice, no? Right. So, if I look at this graph, so now I can take this off. No, that's now explained. So the question says, write down the x-coordinates of the stationary points of f. So in other words, that is where the graph is going to turn. The graph is going up, then down. So you all agree that's what the graph should be. So what are stationary points? Turning points. So number 1. So write down the x-coordinates of the stationary points. X is equal to 2 and x is equal to. If they ask you to classify, what does classify mean? To identify which one is the maximum and the minimum. Sometimes they ask you that as well. Because this is the smiling parabola, the graph first goes up then down. So this is actually a local maximum. And this is the local minimum. If that asks you to classify. Why? Because the graph is turning here. Can you see here? It's turning at 2 at the maximum and it's turning at 4 at the minimum. Okay, but did the question ask you that? No. You don't have to say this. I'm just preempting what or thinking of what the common asked questions around these things are. Okay, so they can touch on all of it. Okay, so that's the answer they're looking for there. Oh yeah, it says classify. Oh my word. Okay, that. So now they're asking you to. Now we are asked to classify the stationary points and justify your answer. So I just did there. So we just say, since the A value has to be positive, so the graph first goes up then down. Therefore, x is equal to 2 is a local, I said maximum, no? Whilst x is equal to 4 is a local minimum. Didn't realize it, but learning so soon. Number 3. Determine the x-coordinate of the point of inflection. Where does the point of inflection occur? Midway, or the axis of symmetry point, not so. So you say x1 plus x2 over 2. It's going to give you 2 plus 4 over 2, which is 3. That's your point of your x value of the point of inflection. Okay. And then draw a sketch of f. I think that is fairly simple. So if I draw this graph, the graph is going to turn at x is equal to 2 and at x is equal to 4. The graph first goes up, then down. And there's your y-axis here. There's your graph. Okay. People, for homework, I would like you guys to do exercise 13. Exercise 13, number 1, 2, 3, 4 and 5. Okay. This deals with what we have covered in this lesson. People enjoy the weekend. Good morning, class.
I want to buy my tips to you for the week.